This video covers a bell ringer review problem for today's Centroids. I want to find the centroid of this shape. It's not something I can do just by looking at it. There's some calculations we need to do. This is still not an overly complex topic to deal with. First thing we need to remember is that right off the bat, we need to fill in our tables before we can end up using the different equations that you see over here. Remember that x bar stands for the x portion of the centroid, the direction that goes left and right. The y bar is the y portion of the centroid. That's the one that goes up and down. Over here in my bottom left hand corner, I've got the total area for each of the shapes. So we're going to go ahead and go through this. I've already done all the calculations, so I just need to fill them in as we go. You, however, may want to try and use your calculators and pause it and see if you can work through that on your own at the same time. So right off the bat, the easiest place to start is to find the area of each of the different shapes. Remember, the area of a triangle is half the base times the height. Both of these triangles are exactly the same size, 8.5 inches by 8.5 inches, the base and the height. To find the total area for that, I just go and do half of 8.5 times 8.5, and it gives me a total area of 36.125. So I'm going to go ahead and throw that in my here in my calculations, which are really hard to see. So let me change the color. And I went ahead and made those shapes 2 and 3. I guess I could probably label all of my different shapes with their numbers. So I have those two areas. I only need to find the last area of the triangle, or I'm sorry, the rectangle on the bottom, and that's base times height. Sorry about the interruption from the intercom, but the base times the height, it's 8.5 inches by 17 inches, and that gives me a total area of 144.5 inches. Okay, so I've got 3 of my portions filled out already. Those different areas I am able to put over here and fill in these sections. Missed one. So at this point, I've already got more than half of my tables filled in, or right at about half my tables filled in. So now I need to find the x portion of the centroid for each of these shapes and the y portion of the centroid for each of the shapes. So to find the x portion, if you remember, the x or the y portion for a triangle is going to be 1/3 base times the height. And that's from our reference point. Remember, we're going to choose our reference point as being there on the far left. So 1/3 the base, in this case, is going to be 2.833. And when we do it with a triangle, we have to do it from the 90-degree angle. So we're looking at here it being from this point to this point, it's 2.833. On this other triangle, going this direction, it's 2.833. We need to remember that because here in a bit we're going to do the distance from the reference point to these, which is just doing some addition or some subtraction. The x portion of the large rectangle, my shape 1, is going to be half of 17 inches, so it's going to be right at about 8.5 inches. The height for this one is going to be 4.25 inches. The height of the triangles for both of them is going to be right here at 2.833. So I think at this point I've got all of my numbers. I just need to figure out how far from the reference point So from this line, how far is this over? So I just take 8.5 and subtract 2.833, and that gives me the number 5.67 inches from the reference point. The height for the centroid of the first triangle, and it'll actually be for both triangles, I'm going to take 8.5 and add 2.833, and that gives me 11.33. So that's my Y, 11.33 inches.
Good morning.
Interrupted yet again. So we've got the height of that one. We know from the reference points of shape 1, that's the actual distance, and this is the actual distance from the reference point. We've still got one more to do, and that's 8.5. That's this portion here, 8.5 to 2 plus 2.833, but we already know. So the X bar of this one is going to be 11.33. And the height of that one is still going to be the 11.33. We already got that over here. And the X, so I've got the X, got the Y on that one. We're all ready to go. So let's go ahead and start filling in the table with the information that we gathered. So for my shape 1, the X is 8.5. Shape 2, the X was 5.67. Shape 3, it was 11.33. For the Y portion of shape 1, it is 4.25. For the Y portion of shape 2 and 3, it's the same at 11.33. At this point, I just need to do the multiplication. And write it in that last column. So for the X portion, it's 1228.25. Then 204.83. Then 48.155. For my Y portions of the centroids, 614.125. 409.296, and I get that for both of these. So remember, before we said the sigma stands for sum, so I've got the sum of all of my X portions times the areas. So this is one number, and that refers to that there. This is the sum of all of my areas, so I just sum all of those up and I just do a simple division. So we'll do that on the next screen here. So my sigma of my xi, ai, so once I add all of those up together, I get 1481.48 for all of my my Y portions. We get 1459.72. My total area is going to be 216.25. So now I just need to do the simple, just throw it right into the formula. So X bar is 1481.48 divided by 216.25, which gives me a number, and my Y bar is going to be 1459.73 divided by 216.25, which is then also going to give me a number. So the X portion of our centroid, the number comes out to be 6.85. The Y portion of my centroid is 6.75. So if I were to go back to my original drawing and draw where it is. So from the left it's going to be 6.85, and going up it's going to be 6.75, and that'll be the center of this particular shape.